So if I've done my job right, first of all, Logan and Sam, if you really focus and pay attention, you might pick up what we did last lesson in today's lesson. If I've done my job right, Justice, this should be, I never thought of that, but that makes sense. All we're going to do is say, okay, let's make the circuits more complicated. Okay? Mixed circuits have both series and parallel parts. Come back here. There we go. To solve these, identify the series and parallel. Now it finally moved. It's a bit of a delay when I scroll down. There we go. You guys with me? Good, Shush. To solve these, make sure you identify what's series and what's parallel. Simplify it to its mathematically equivalent circuit. One resistor to rule them all. One, whatever the dumb way you want to remember it. And then find the total current. How? Total current is going to be total voltage, which is going to be your voltage source, your chairlift, your battery, divided by total resistance. It's I equals V over R. I total equals V total over R total. And then use Kirchhoff's rules. Ski and currents. So example 1 says, identify resistors in series or parallel. I'm going to call this R1, R2, and R3. And you know what? I'm going to let each of these be five ohms. Which ones are in parallel? 2 and 3. R2 and R3. Okay? Let's write this as one massive resistor. First thing that I would do is I would say 1 over R parallel, and there's my abbreviation for parallel. Hey, we've seen that before, Mr. Dueck. Yeah, I'm bringing it back from forces, I think. 2 lines is parallel. Is going to be 1 over R2 plus 1 over R3. That's going to be 1 over 5 plus 1 over 5. What's R parallel the same as? What can I replace those 2 resistors with? Do the math, please. I hope 2.5 ohms, yeah? You get 1 over 5 plus 1 over 5 is 2 over 5. For those that were away, Sam and Logan, what you're going to do on your calculator is 1 divided by 5 plus 1 divided by 5. And then all of you somewhere have a little x to the negative 1 button, a reciprocal button. Hit that for the answer, and that flips your answer. This is the same. In fact, if I was going to redraw this as its mathematical equivalent, which I'm going to do over here because I'm going to draw the other one for the next question right there, just kind of planning this out. I have a voltage source, a 5 ohm, and a 2.5 ohm. Is that okay, Atla? Mathematically, those are equivalent. And notice in my new drawing, the 2 mathematical resistors that I've drawn are in series or parallel. So what's the total resistance of this circuit? Now you could say R total equals, we'll write in our notes, 5 plus 2.5, 7.5 ohms. And if I told you the voltage, you're good to go. Okay. R1 equals 4 ohms. This little middle resistor, R2, is also going to be 4 ohms. And then just for giggles, let's let 5 ohms, 5 ohms, 5 ohms. Mr. Dueck, you didn't label those other three. Yeah, I know. What do you notice about those 5s? They are in. Mathematically, those 3 5s, Jake, are the same as one single solitary what? Okay. 1 over R parallel is going to be, do you see it? I can combine that 4 and that mathematical 15 equivalent, and I can replace that huge mess with one over 4 plus 1 over 15. I doubt this will work out evenly, but maybe. 3.1, yeah, okay. 3.158. Ohms. This whole mess is that. But that whole mess is in series with that 4. Because there's no junctions between that 4 and that whole mess. So, our total would be 4 plus 3.158. 7.158. And I would probably use my answer button because I'm willing to bet if I'm lucky, maybe, carrying those extra decimals when I start dividing later, maybe I might get an even answer. Maybe not. It's very tough to make these work out evenly, Emma. As soon as I go anywhere medium complicated, I give up on trying to make them work out evenly. So usually for a resistor, I'll carry 4 or even 5 sig figs. Is that okay? I'm not going to label this last one, but which ones are in parallel? These two? Is there another group that's in parallel? These two. So if I was rewriting this, I would rewrite those two as one single one by going 1 over whatever they were plus 1 over whatever they were, reciprocal. Rewrite those, and then I would have 3 in series, add them up. And then I'd have R total, and it falls apart. Let's do some. Oh, here's another one. Okay, you know what? Let's go to example 2 and just do some of these. Says find all voltages and currents, draw a summary diagram. In other words, draw its mathematical equivalent. We will draw the mathematical equivalent. Some of you will get good enough that you don't need to completely redraw the circuit, and I'll show you some shortcuts that we can use along the way. Hey, what did I say we always want to try and find first? Total current. Did they give me total current? Did they give me any current? Usually that's a sign that you're probably going to have to rewrite this circuit. Double check. Is there anywhere where they've told me 2 things? Nope. Will skiing help? Well, I mean, for what it's worth, don't write this down. I know that has to add to 20 volts, because otherwise how could I get to the bottom? And I know that these are going to have to add to 20 volts, otherwise how could I get to the bottom? But that's going to be for later. Let's call this R1, R2, R3. Which ones are in parallel? So, you know what? Since they're on the right side, I'll show my work here. If I'm marking your tests, I would look for this step somewhere. You don't have to show me all your V equals I times R stuff because that's calculus. You can, but I would certainly look for 1 over R parallel equals what plus what? 1 over 10 plus 1 over a 5. And I've told you I'm fussy. I don't like putting an equal sign there because 1 over 15, sorry. I'm fussy. I don't like putting an equal sign there because they're technically, I'm going to be doing the reciprocal now. So I'm going to draw a little arrow. What is 1 over 10 plus 1 over 15 and then reciprocal of the answer? Oh, works out evenly? Nice. I really should memorize some combinations that work out evenly, and then I'd look really smart. 6 ohms. So, I would give you almost certainly 1 mark if I saw that. Then I would say I would give you 1 mark if I saw, all right, what's the total resistance of this thing? Now, just this time, I'm going to redraw it. Here's what we now have. 20 volts. we have a 4 ohm resistor, and we've just said these are the same as a 6 ohm resistor. If you find you're comfortable, Ryan, not redrawing that step, if it's a simpler circuit, I don't give marks for redrawing it. If it's you'll see some complicated ones. If it's a complicated one, I still tend to redraw it if it's really, really yucky. But hey, what's the total resistance of this circuit? That I would give you 1 mark for. Total current is total voltage divided by total resistance. What's the total voltage of this circuit? And that's going to be your voltage source. 20 divided by 10. Hey, nice. 2 amps. Did we just find total current? I'm telling you, the question's going to fall apart. I don't know how yet, but it's going to fall apart. Now what? Well, I almost always want to remind myself I have 2 amps leaving here. Why does that help? What else did that tell me? Ashley, you just pointed. In which resistor, what? In R1? Oh, wow, I labeled them. R1. Yeah, there's 2 amps. So, why is that so nice? Do I know 2? Well, then I know 4. I'm not going to find power, though. I can certainly tell you the voltage drop in here. I times R. Heck, I can even do it in my head. 8 volts. So if I was marking this, I would give you 1 mark if I saw that, 1 mark if I saw that. Then the next thing I would go hunting for would be that right there, and I would say 1 mark. Why is that so nice? What other voltage does that instantly tell you? R2 and R3. In each of those, what do you lose? That would probably give you a mark and a mark. You okay with that, Shelby? We skied in our heads, right? 20 take away 8, that one's got to be 12. 20 take away 8, that one's got to be 12 as well. Is that okay? Why is that so nice? Because now in each of those I know 2. I can find current. How many amps in this 10 ohm resistor in R2? 12 divided by 10, 1.2 amps. How many amps should be flowing through the right-hand resistor? If my total is 2, it better be 0.8. Let's double check just for giggles. Does it work out to 0.8? If I go 12 divided by 15? And that would be 1 mark, 1 mark. So these work really well. I can give you lots of part marks. The only risk is if you make a mistake at the beginning, it's going to domino all the way through. Much like my mistake in going over the homework, Vanessa, earlier today. Thank goodness I didn't record that on YouTube. At least YouTube thinks I'm smart. Go back before I turn the page. Did I answer the question? What do they want me to find? All voltages? Check and check. Oh, and draw a summary diagram. There it is. There you go. All I can do is kick things up a notch. You guys stay on example 3. Folks, stay on example 3. But I'm going to tell you, example 3 is the same question as example 2. No, it's not. Yes, it is. No, it's not. Yes, it is. Except all I did was instead of giving you 1 resistor, I gave you 1, 2, 3. But aren't they in series? Yes? Well, then you know what? I'm going to pretend it's the same question. What is this really? A single resistor, how big? 20. You guys with me? 20. I tend to, if they're in series, just add them up, unless it's yucky numbers. So we're going to do this just like we did before. 1 over R parallel is going to be 1 over 5 plus 1 over what? 20. Now, stop, look up. Just so that you can see what we did, let's write this in our notes. You do not have to write this in your homework, but down here, let's write R series equals 12 plus 6 plus 2, 20 ohms, just so that when you're studying, you know what the heck we did. What is our parallel? 4? Nice. So, the mathematical equivalent to this circuit is a 30-volt source. What's the resistor up top here? How big? I've scrolled down. What's the resistor up top here? How big? 6. And you've just told me that whole mess can be replaced with that. Ah. What's the total resistance? By the way, I didn't lie to you. I told you this was, what was the total resistance of the last circuit, by the way? Question, Carly? No, because I might have gone too fast, right? These are in series. That's a 20 ohm resistor. And now it's, sorry, got to be careful, Mr. Dueck, I circled the 5. These are in series. That's a 20 ohm resistor. And now I'm telling you it's a 5 and a 20. It's the same question mathematically. In fact, I wasn't kidding when I said it was totally the same question, because don't you also get 10 ohms again? And don't you get I total being 20 over 10, 2 amps again? Oh, it's 30 volts. You know what? I should have made it 20 volts. That would have been perfect. Anyways, 30 volts, so okay, I lied. 3 amps. What did we just find, Ryan? It's going to fall apart. Right here, I have 3 amps. Oh! What does that help with? I know up here, 3 amps. Then it splits up. Don't know how. Oh, but how many volts up there do I lose? 18. Leaving how much, Shelby? And I notice that I can ski this run here. Ah, how many volts do I lose in that 5 ohm resistor? How many volts do I lose in this 5 ohm resistor? 12. 30, lose 18, I got 12, and that gets me to the bottom. I lose 12 volts going through here. Yeah? Hey, let's fill that in. Oh, do I know 2 things? Well, then heck, I can tell you the current in this 5 ohm resistor as well. It's going to be V divided by R. It's going to be 12 divided by 5. Help me out. 2.4? Why is that so nice? What else do I now know? I think I know how many amps went in the other branch. How many amps went down the other branch? 0.6 amps, 0.6 amps, 0.6 amps. You know what? I know the voltage drops in each of those too now, because I can go I times R. In that top one, it's going to be 0.6 times 12, 7.2 volts. Double check me. In this middle right-hand one, 3.6 volts. Yeah? And 1.2 volts. Double check me, I'm doing the math in my head. Yeah? Now, Shelby, I'm picking on you because you're looking really tired this morning. Look up, kiddo. How many volts going down this path, grand total, did I lose? 12. Were we able to shake hands and meet up going down this path? I bet you, well, that means I have to have lost a total of 12 volts in the other path. If you add 7.2 and 3.6 and 1.2, please tell me, do you get 12? Well, hey, there's our check. Couldn't have fluked into that. We must be right. Last thing I do, Jake, I answer the question. They said find all voltages and currents, draw a summary diagram. Now, this is a fairly good test question. Probably what I would say is how many watts of power in the 6 ohm resistor, or in the 2 ohm resistor, because there's 2 6 ohms. I would say how many watts of power. And to find how many watts of power, I got news for you. You got to find all the other stuff first and then go V times I. Okay? What happens to the total current when the switch is closed? Now, I'm going to put in brackets when we add a resistor in. When I close that switch and that 10 ohm resistor becomes part of this circuit, is it in parallel or in series? Atla. Okay? I'm going to tell you the answer and then we're going to prove it. It turns out when you add a resistor in parallel, when you add a resistor, total resistance goes down in parallel. Now you may say, wait a minute, Mr. Dueck, you just added a resistor. Shouldn't total resistance go up? I opened another ski run. If it's in parallel. I opened an entirely different pathway. Total resistance is going to go down. It's like if you have a crowded hallway, even if you open up another very crowded hallway, it's going to get better. The total resistance has gone down. If you have a crowded hallway and you add another crowded hallway in series, that's not going to speed things up. That's going to increase your resistance because there's going to be two backups. So I'm telling you, let's prove it. Here we have numbers. Let's go open and closed. With the switch open, that means this isn't part of the circuit at all. I have two resistors, the 20 and the 5. Are they in series or in parallel? Okay, so, ready? With this open, what's our total? 25. What's V total? 100. So what's I total? 4 amps. 4 amps. Gesundheit. What about when we, is that okay? What about when we close the switch? So really what this question is saying is, if you close the switch, is it more than 4 amps now or less than 4 amps now? Or the same? I don't think it's going to stay the same. Well, first I would have to go 1 over R parallel is 1 over 5 plus 1 over 10. What's R parallel equal to? 3.33333? What's R total equal to? So you're telling me this is the same as a single 3.333 resistor in series with that 20. I think R total is going to be 20 plus 3.333. Our total is going to be 23.333. Is that okay, Holly? So, what's I total? It's going to be 120 divided by 23.333. 100, got 120 on the brain. 100 divided by 23.33333. Current goes up, yeah? What do you get? 4.3? Okay. You can think of it this way. You know what? If you open another trail, you can get more skiers on the same mountain, more current. Okay? If you don't open another trail, but you just put a hill in series, I'm sorry, you can't get more skiers on the mountain. There's only so many people that you can fit off the chairlift. But a whole other trail, we can plunk a bunch of people in there. says explain your answer using relevant concepts of physics. We just did. What's your homework? Lots and lots of practice of this. So certainly, number 1. Wow, short lesson, Mr. Dueck. Yep. Number 2. 3 is good. 4 is good. Mr. Dueck, in number 4, they didn't tell me which way the current is going. It's just saying find the mathematically equivalent resistor. Ooh, Mr. Dueck. Number 5, with that battery in a weird location, I think the first thing I would do is label my arrows. Which way is the current going? Number 6. 7. 8. Hang on. From Ultimate Review, you can now try 1, 2. Can you cross out number 3? I'm going to get to that at the end of the year. 4. 5. 8. 11. 12. These are good indications of the kind of written questions you're going to have. 13. 16. 17. 18. 21. And 23. There's a good start. Okay.